Alright, so here we are in the third and final video for working technician license level math questions out of the total pool of questions. So let's move onward and upward. Okay, what is the resistance of a circuit in which the current of 3 amps flows when connected to 90 volts? And as I've mentioned before, I always start with E equals the current times the resistance. Now here they're asking us for the resistance. So if I divide both sides of this equation by I, the i's cancel out on this side, just leaving R by itself. So R then is equal to E over I. Now I did this quickly. You can review the other videos to actually see the algebra. But I would write these on the margin of your test or on a scratch paper. I think they give you a clean sheet of paper. And most of them provide calculators. They don't really like you bringing your own calculator unless it's just a really simple scientific calculator like the Casio that I have. It can't store anything. Okay. But we want resistance here, so let's use that. Resistance is the voltage, which is 90 volts, divided by the current, which is 3 amps. 90 divided by 3 is 30, so this is 30 ohms, and that's answer B over here. Okay, so what is the resistance of a circuit for which the applied voltage is 12 volts and the current is 1.5? So again, we have resistance then is equal to the voltage, 12 in this case, divided by the current, 1.5. And I'm going to do that on the calculator. 12 divided by 1.5, and that gives me 8. So this equals 8 ohms. And there's my answer right there of 8. What is the resistance of a circuit that draws 4 amps and 12 volts? Again, it's the same formula. They're wanting to know resistance, and that's equal to the voltage, 12, divided by the current, which is 4. Well, 12 divided by 4 is 3, so we're looking at a 3 ohm resistor. Okay, what is the current in a circuit with voltage and resistance? So again, we need to get the current one, and I've already done that up here at the top. No, I didn't. Okay, so if I want the current isolated here, so I is on one side, everything else, divide both sides by R. So I then is equal to E over the R. All right, so let's go down here and do that. I then is equal to the voltage, 120 volts, divided by the resistance, which is 80 ohms. Take that off. We got 12 divided by 8. And that's going to be 1.5. 3 over 2 is 1.5. So our current then is 1.5 amps. And there's our 1.5 right there. Okay. What is the current through a 100 ohm resistor connected across 200 volts? So again, the current is equal to the voltage divided by the resistance. So this is 200 volts divided by 100 ohms. This goes in exactly 2 times. So our current then is 2 amps. Okay, what is the current through a 24 ohm resistor with 240 volts? So we have 240 volts divided by 24 ohms. And we're going to get 240 divided by 24 is 10. So it's going to be 10 amps. That better be a heavy duty circuit. 10 amps is a lot of current. Okay. Now we want to know voltage. What is the voltage? So this is our straightforward Ohm's law, E equals current times resistance. So let's fill it in. E then is equal to our current 0.5 times our 2 ohm resistor, and 2 times 0.5 is equal to 1. So 1 volt. What is the voltage across a 10 ohm resistor with 1 current? 1 amp of current. So that's just 1 times 10. And when you're multiplying, the order doesn't matter. So yeah, this is the resistance times the current, but same thing. They're interchangeable. And 1 times 10 is just simply 10. So we are going to have 10 volts across that, which is B. Okay. What is the voltage across a 10 ohm resistor of 2 amps? And 2 times 10 is 20, so we are going to get 20 volts. And that's answer D. Okay. The last two are a little more complicated. These are not Ohm's law problems. What is the approximate length in inches of a quarter wave vertical antenna for 146 megahertz? Okay. So a half wave is equal to 468, that's a magic cookie number, over the frequency in megahertz. This number up here is really kind of a conversion factor that comes from how radio waves travel through space versus how they travel in a wire here on this planet. Okay. So we will just accept that. The derivation of that is a lot more complicated than I want to get into, and certainly beyond the scope of this video. Okay, so let's just plug our stuff in. We get 468 divided by 146 megahertz, and when we do that, 468 divided by 146, this gives us in feet 3.2 feet for a half wave length. So what is that in a quarter wave? We could divide this in half again. Let's see what happens there. And we get 1.6 feet, but we want inches. So we have 12 inches plus 6/10 of another foot. Well, 5/10 of another foot would be 6 inches. So it's got to be a little something over 6 inches. We can get that if we take 0.6 tenths of a foot and multiply it by a conversion factor of 12 inches in 1 foot to 10 tenths in tenths here. Just do it with this part. So 6 times our fraction of 12 over 10, and yes, you can reduce the fraction first if you want, and we get another 7.2 inches. So if we add 7.2 inches here, we get 19.2 inches is the length of a quarter wave. And they're not using any decimals there, so the closest one to it is actually 19. So C is our answer. A little tricky because they don't put in the book about converting tenths to inches, but that's all you do. You can get the you know how many inches are in a foot, so we had 36 inches total there. Okay, let's do the next one. Now, what is the approximate length in inches of a half wave for a 6-meter dipole? Well, first of all, 6 meters, that's the length of a full wave. And we'd have to convert between meters and feet. And let's use the same thing. We have a half wave. That's the full wavelength divided by 2 is equal to 468 in divided by the frequency in megahertz. So what is the 6-meter band? Well, if you look that up, you'll see that it's about 50.1 megahertz. Matter of fact, they do this exactly in the technician book. All right. So let's do that calculation. We have 468 divided by 50.1. This tells us that it is 9.3. We'll just round it to 9.3 feet. But again, they want it in inches. They like to torture us with that. So how many inches are in 9 feet? Well, that's just 9 times 12. So 9 times 12. And we see that this is 108 inches plus whatever a third of a foot is. Well, 3 goes into 12 4 times. Let's see, does that help us any? Third of a foot is 4 inches. 3 times 4 is 12. So a third of a foot is... what did I just say it was? 4 inches, yeah. Plus another 4 inches. That gives us a total of 112 inches. That matches with answer C. Okay, I hope that helps. We're a little bit over time, but that finishes up the math-related questions in the technician. So good luck to you taking that test. Do some practice with the calculations, because when you're sitting there at the table actually taking the test, most of us kind of stress out a little bit or register some level of stress when we're taking a test, particularly math. So make sure you account for that. See you in the next video.